Lecture 25. Surprising Truths About Everyday Objects Introduction. The most extraordinary mysteries aren't hidden in distant galaxies or microscopic realms. They're right in front of you, disguised as ordinary. I'm standing here holding 5 seemingly mundane objects: a microwave, a mirror, a pencil, a smartphone, and a refrigerator magnet. But each harbors secrets so profound, so perplexing, they'll transform how you perceive the fabric of your daily existence. What if I told you that the objects you've taken for granted your entire life are windows into quantum physics, celestial phenomena, and technological marvels beyond imagination? Today, we peel back the veil of familiarity to expose the bewildering truths hiding in plain sight. The microwave miracle, that humming box in your kitchen, a portal to understanding light itself. The microwave oven entered our homes through a delicious accident. In 1945, engineer Percy Spencer stood near a magnetron and noticed the chocolate bar in his pocket had mysteriously melted. This serendipitous moment revealed that certain electromagnetic waves could excite water molecules. But here's what's truly mystifying. When you heat your leftovers, you're bathing your food in invisible light. Microwaves are actually a form of electromagnetic radiation, cousins to visible light, just with longer wavelengths our eyes cannot perceive. Why does metal spark violently in a microwave while ceramic remains placid? Metal objects trap electrons that, when bombarded with microwaves, frantically race across surfaces, creating electric arcs, miniature lightning storms in your kitchen. But perhaps most captivating is this: your microwave's wavelength, precisely 12.2 centimeters, was chosen not for optimal cooking, but because it wouldn't interfere with telecommunications. Your kitchen appliance operates at exactly 2.45 gigahertz to avoid disrupting the conversations of others. Mirror MYSDRIS. Now, gaze into this mirror. A portal not to another dimension, but to a profound philosophical puzzle. Have you ever wondered why mirrors reverse left and right, but not up and down? This enigma has perplexed minds for centuries. The truth? Mirrors don't actually reverse left and right at all, they reverse front and back. When you raise your right hand, your reflection raises what appears to be a left hand because you're facing each other, not because the mirror flips horizontally. The mirror's silvery depths aren't merely reflective glass, but a precise sandwich of materials. Modern mirrors typically employ aluminum vapor deposited at molecular thickness behind glass, a process developed to replace the toxic mercury used in antiquity. And that one-way mirror in detective shows? A captivating misnomer. No mirror is truly one-way. They're partially silvered glass that exploits the imbalance of light between a bright and dark room. When the observed space is brightly lit and the observation room is dark, the reflective surface becomes transparent to those in the shadows. The humble pencil, this unassuming writing implement, a cosmic artifact born in stellar furnaces. Despite being called lead pencils for centuries, they contain no lead whatsoever. The dark core marking your paper is graphite, pure carbon arranged in honeycomb sheets that effortlessly slide across one another, leaving traces on surfaces they touch. But here's what's truly enchanting. The carbon in your pencil shares its elemental identity with diamonds. Both are carbon, merely arranged in different atomic architectures. Pencil lead and the most precious gemstones, cosmic siblings forged in the hearts of dying stars billions of years ago. When you write, layers of carbon atoms, each connected in hexagonal patterns, shear off onto paper. This microscopic ballet of molecular structures allows your thoughts to become visible, all because carbon atoms prefer certain geometric arrangements over others. Next time you sketch or write, pause and consider. You're manipulating stardust arranged in one of nature's most elegant molecular structures. Shocking smartphone SECRETS, that device rarely leaving your side. A geological wonder containing elements from across the periodic table. Your smartphone harbors approximately 75 different elements, roughly 2/3 of all known elements. Among them are some of Earth's rarest materials: neodymium for its tiny magnets, indium for the touch-sensitive screen, and terbium that makes its display glow with vivid colors. More perplexing still, the gold in your phone exists in higher concentration than in most natural gold ore. A ton of iPhones contains 300 times more gold than a ton of ore from gold mines. The screen responding to your touch isn't detecting pressure, as many believe. It's measuring something far more ethereal, the electrical properties of your body. When your finger approaches the glass, it distorts an electrostatic field, creating a capacitive effect that the device interprets as touch. And that smooth glass surface. It's likely made of aluminum silicate infused with potassium ions, a material so resilient it can only be scratched by materials like topaz or sapphire. Refrigerator revolution finally, that quiet sentinel in your kitchen, a thermodynamic marvel defying entropy itself. Contrary to intuition, refrigerators don't generate cold, they remove heat. This seemingly subtle distinction reveals a profound truth about thermodynamics. Cold isn't a property that can be created, only the absence of heat energy that can be engineered. The cooling coils extract thermal energy from inside and expel it behind the unit. A one-way valve for heat, constantly working against the universe's tendency toward thermal equilibrium. Early refrigerators used toxic ammonia, sulfur dioxide, or methyl chloride gases, substances so dangerous that leaks could cause fatal accidents. A series of deadly refrigerator explosions in the 1920s led to the development of safer coolants. These cooling technologies fundamentally transformed human civilization, extending food preservation from days to months and enabling the global food distribution network we now take for granted. Conclusion: the objects surrounding us aren't merely tools or conveniences, they're portals to understanding the fundamental principles governing our universe. As you move through your day, I invite you to pause and consider. What other mysteries might be hiding in your pencil drawer? What cosmic phenomena are at play in your kitchen cabinets? What quantum principles underlie the technology in your pocket? The most profound scientific truths aren't locked away in laboratories. They're embedded in the ordinary objects we've stopped seeing with wonder. Next time, we'll explore common health myths that might be influencing your daily decisions. Until then, look closely at the familiar, for in it lies the truly extraordinary.